Hello everyone, welcome to our project, Cross-Domain Sentiment Analysis on the Financial Data using Unsupervised Self-Training Algorithm. When blogs, reviews, and opinions became easily available online, sentiment analysis suddenly became an interesting research area. Sentiment analysis, sometimes also known as opinion mining, aims to understand and classify the opinion, attitude, and emotions of a user based on the text. Sentiment analysis has many applications, including understanding product reviews, social media monitoring, brand monitoring, reputation management, and etc. The most common use of sentiment analysis in the financial sector will be analysis of financial news, in particular to predicting the behavior and possible trend of stock markets. So, what is the problem we are dealing over here with? The problem is the scarcity of the datasets. We don't have enough datasets, firstly, and secondly, the ones we have, those are too small to capture the nuances of financial language. Hence, it generates the requirement of unsupervised models. Usage of cross-domain sentiment data will help the model to better understand the sentiment. Our task was the cross-domain re-implementation of the novel approach presented in the paper, in which we pre-train various BERT models on the Twitter sentiment data and then perform unsupervised self-training on financial sentiment dataset. First, we perform supervised learning using social media sentiment data, and then we perform fine-tuning using unsupervised self-training on financial sentiment data. We use two datasets. The social media sentiment data used is Twitter sentiment data. This dataset includes topics based on popular events that were trending on Twitter internationally. The range of topics included were Donald Trump, Western media, gun control, vegetarianism, and etc. The financial sentiment data used is Financial Phrase Bank. The dataset is a public dataset for financial sentiment classification. It contains about 4840 sentences obtained from financial news labeled as positive, neutral, and negative. The baseline models we are using are BERT, firstly, the vanilla BERT model, secondly, the Robeta, which is improved BERT by modifying key parameters, FinBERT, the base vocab, BERT-based model further trained on financial corpora, and FinBERT FinVocab. The model is trained from scratch using new uncased and cased financial vocabulary FinVocab for over 1 million iterations. The above models are trained on Twitter sentiment data in the supervised manner. The fine-tuned models obtained in this way are further trained using the unsupervised self-training algorithm. We begin by producing zero-shot results for sentiment classification using a selected pre-trained model training on the same task. From the predictions made, we select the top n most confident predictions made by the model. The confidence level is being judged by the softmax scores of the final prediction layers of the model. We then use the selected as pseudo labels predicted by the zero shot models to fine tune our model. After that, the predictions are made on the remaining dataset with the fine-tuned model. We again select top n most confident predictions made by the fine-tuned model to fine-tune the model again and loop back the steps. These steps are repeated until we have exhausted the entire dataset or until the stopping conditions has been reached. All the fine-tuning steps, we only use the predicted pseudo-labels as the ground truth to train the model, which makes the algorithm completely unsupervised. Macro average recall values are shown for the supervised learning for validation and test sets. Robeta is the best model and its performance is close to the best performance reported in the TweetEval paper. Since the Twitter sentiment data has no explicit overlap with the financial data, FinBut and FinVocab performs poorly. Next, the unsupervised results. The 3%, 5%, and 7% is the N we talked about in the explanation to generate the pseudo labels for the most confident 3%, 5%, and 7%. This algorithm gives a decent alternative to the counter algorithms in the supervised learning, especially in case of scarcity of the labeled trainable datasets. The same challenge is also being countered using the approach of cross-domain learning. The approaches being used in the algorithms are easily transferable and can be used over different problem statements and datasets. Thank you.